In case you're not familiar, I thought I'd start off just to level set everyone and refresh everyone what sound intensity is. And in order to do that, we're a big fan of using this heater analogy. So if we buy a heater at Home Depot or somewhere and we plug it into the wall and we turn it on, we know it's going to make the room warmer, right, if it's functioning. And if we were to make temperature measurements around the room with a thermometer or a thermocouple, that would be equivalent to making a sound pressure measurement with a microphone. It's good for a time and a position, and it's just a number, right? We get a temperature at a specific location on the couch back there, for instance, versus the flower pot. That's temperature, sound pressure. If we were to look at the back of the heater and see how many watts of electrical energy it's going to consume and convert into heat, that would be equivalent to its sound power, which we also sort of rank in watts, a unit of power. And that is the, in the acoustic sense, the sound making capability inherent to this sound source. Okay, so we call that sound power. If we were to talk about how the heat leaves the heater and gets throughout the room to the other objects, we might talk about the heat flow and describe how much of the heat power or watts comes through any unit area or watts per unit area. That's equivalent to the sound intensity. Some of the heat's going to come out, or the heat's going to come out faster at some parts of this heater than others. Same with sound sources and sound intensity. We use a watts per unit area and we get sound intensity. And the important thing to understand, the reason we need, or one of the benefits we'll get from using more than one transducer in our intensity probe, is that we don't just get a number. Like sound pressure is a scalar quantity. It's just, in this case, 45.3 dB in terms of Pascal. It's just a number. That's all we get. With intensity, because we're using more than one transducer, we can actually calculate something that's a vector quantity, and it says it's 46.1 dB watts per meter squared in this direction, the direction of that arrow. Okay, so sound intensity has this directionality to it, a vector quantity that we don't get with just a sound pressure measurement. Okay, we're going to use that to our advantage when we do it for sound source localization. So sound intensity is a vector quantity. This is a picture of a common intensity probe. It's got two microphones, and then that black piece of plastic in the middle is called a spacer. And using this tool, we can measure the sound intensity directly. And we call sound intensity the average rate of sound energy transmitted along a certain direction. So let me change my pointer to a laser pointer here. And so this probe, because it has two microphones, it can only measure sound intensity along the axis of the microphones or along the axis of the probe, okay? If the sound's flowing this way, we're not going to be able to measure it because the microphones are out of that vector orientation, okay? So we measure sound intensity in a particular direction. It's going to be really important when we start to use these things. We have to keep that in mind. And intensity is really just the sound pressure multiplied by the particle velocity. If you do the units carried out, you end up with a watts per meter squared. And if you remember on that last slide, my sound power was also in units of watts. And so there's a link between sound intensity and sound power. And so we'll talk about that in just a little bit as well. But a useful side effect of sound intensity is sound power. And it's, of course, dependent on how close you are, the direction you're facing, etc. So if we wanted to measure the sound intensity on this sound source, we're going to have to sort of describe or lay out an area over which we're going to make these measurements with our intensity probe. In this case, we're going to measure the sound intensity over this speaker, and we're going to do some sound source localization. Okay, so using an intensity probe for sound source localization, we're going to make a measurement at this first grid point, and we're going to measure for 30 seconds or so, let's say, and then we're going to move to this grid point, and we're going to make another measurement, and so on until we fill up this whole grid. Okay, and we have a total of 42 measurements. Each of them is 30 seconds long, and so we spent, a significant amount of time making this measurement. So it's not a fast measurement by any stretch of the imagination, but we'll also be able to calculate the sound power. So this is, if you recognize, this is a sound power label. So we'll know what the inherent sound making capability of this device is in terms of sound power, but then we'll also be able to extract the sound source localization information. So you can see via this contour plot, most of the sound energy is coming out of this area shown in red, you know, sort of the generic in green, and then very little of the sound intensity is coming out of this woofer port up here. And so we can actually figure out where on our device the sound is coming from. This is sound source localization, okay? And this is what it typically looks like using an intensity probe.